Hi everybody. You would have come across this question: 81 raised to the power of sine squared x positive 81 raised to the power of cos squared x is equal to 30. You're expected to solve. Now the solution provided by the video maker, the content maker, which is apparently available on the social media, has taken a very long approach. Now this question be a competitive examination question. The faster you get the solution, the better you are. So I'm going to be providing you an alternative way to solve this question, and which can be actually done in a quicker manner. Now what I wish to do is I would like to rewrite this quantity 81 raised to the power of sine squared x as, along with positive cos squared x is equal to 30, as 81 raised to the power of sine squared x positive, this is going to be 81 raised to the power of 1 negative. Now we know that cos squared x is equal to 1 negative sine squared x. So I'm going to substitute that. So it's going to be 1 negative sine squared x is equal to 30. And then I know a formula a raised to the power of m negative n is a raised to the power of m times a raised to the power of negative n, which could be rewritten as a raised to the power of m over a raised to the power of n. So that's exactly what I wish to do. I would like to rewrite this as 81 raised to the power of sine squared x positive 81 raised to the power of 1 times 81 raised to the power of negative sine squared x is equal to 30. This could be however rewritten as 81 raised to the power of sine squared x positive 81 over divided by 81 raised to the power of sine squared x is equal to 30. Now you could have avoided all the steps. Now just to have some clarity, I have just written all this, so you can directly come right from here to here. Probably that would have taken you 2 seconds. Now this is where I am planning to make the substitution. In fact, I would like to make the substitution over here. That's why I started with saying let. So I'm going to use that let over here. So let 81 raised to the power of sine squared x be equal to some p. So this would mean if I were to take this as 2, therefore 2 can be rewritten as, in place of this I need to place p, in place of this it's going to be 81 over p is equal to 30. This is what we have got. Now the question is it possible for me to rewrite this in a quadratic equation form? Of course, yes. So that would be possible if I were to multiply by p throughout. So this is going to be p squared positive 81 times p. In fact, p and p will get cancelled. So let me just place that, and 30 times p. Now this is rewritten as p squared. As I mentioned to you, we would get rid of this. In fact, the p is lost. So 81 is there. Now let me just bring this positive 30p to the left. So that's going to be negative 30p. Positive 81 is equal to 0. This could be rewritten as p squared negative 30 times p positive 81 is equal to 0. This is what we have got. Now if I were to take, if alpha comma beta are the roots of this quadratic equation, are the roots of say 3, I'm taking this as 3, then we have studied that the sum of the roots alpha positive beta is equal to negative b over a. So that would mean in this case it's going to be negative, b is negative 30, a is 1, which is going to be positive 30. So we got alpha positive beta is equal to 30, and the product of the roots alpha times beta is equal to c over a. In this case is going to be 81 over 1, which is nothing but 81. So let me write that down, 81 over here. Right now alpha plus beta is equal to 30. Now can you take a guess what would be the value of alpha and what would be the value of beta, so that we can get 30. Now the same alpha and beta, if I were to place them over here, when I multiply, I should be in a position to get this quantity 81. Now let me just take alpha to be equal to 3 and beta is equal to 27. Now what happens when you add 3 positive 27? What do you get? You get 30, right? Now what happens when you multiply 3 into 27? What do you get? You not get 81? So clearly you can see the roots are alpha is equal to 3 and beta is equal to 27. However, you can take alpha is equal to 27 and beta is equal to 3. It doesn't matter. Now this is what we have got here, right? Now from here the solution is straightforward. Now let me just consider alpha is equal to 3. Now the meaning is the root is 3. That would mean we are actually substituting the value of alpha being equal to 3 over here. So P takes the value of 3, right? So this would mean my P will be equal to 3, which would be substituted here, and the outcome will be producing me the result 0. That is the understanding. So having obtained that understanding, if P is equal to 3, what is the actual outcome? What does this mean? I have taken P to be as, clearly you can see P is 81 raised to the power of x squared. So write that down. 81 raised to the power of sine squared x is equal to 3. So this is what we have got. Now is it possible for me to express 81 as a power of 3? 3 to the power of 4? Would it be giving me 81? Let me see that. 3 multiplied with 3 multiplied with 3 multiplied with 3. 3 3s are 9. 9 3s are 27. 27 times 3 is giving me 81. So that is perfect. So let me write that down. So 3 raised to the power of 4 times sine squared x is equal to 3. This is what I get. Now we know algebraic law. If a power m is equal to a to the power of n, if the bases are same, then this would mean m is equal to n. So the bases are same here. So this would mean 4 times sine squared x is equal to 1. This in turn would mean sine squared x is equal to 1 over 4. This in turn would mean sine x is equal to plus or minus 1 over 2, right? Now if sine x is equal to positive 1 over 2, let me just take this value. That would mean x is equal to, this is possible when x is equal to 30 degree, right? But 30 we can write 30 as pi over 6. Now if you want to generate all the solution, x is going to be pi over 6 positive 2n times pi. So this will be the value of x. Now x is equal to pi over 6 is not going to be the only value that is producing me 1 over 2. Now if I were to take, say, sine 150, sine of 150 will also give me 1 over 2, right? So I need to take that value also. So also you can write that x is going to be 5 pi over 6. And followed by, you need to add 2n pi. So this is going to be one set of solution when x is equal to 1 over 2. Now x is also negative, I mean in other words sin x is also equal to negative 1 over 2. Now if sin x is equal to negative 1 over 2, so this would mean, when would this be possible? This would be possible if x is equal to 7 pi over 6. And since we are actually generating all possible values, you add 2 times n times pi. Now negative 1 over 2 will also be possible for 11 pi over 6. Now this is from the unit circle, I am just obtaining the values. And to generate all values, this is going to be 11 pi over 6 positive 2n pi. So this is going to be one set of values. So we need to take this beta is equal to 27. So beta is equal to 27. What does that mean? The other root is what? 27. So this would mean my p is equal to 27. This would mean 81 raised to the power of, since p is 81 raised to the power of sine squared x, right? So that is the substitution we started with. 81 raised to the power of, it's not 4, 81 raised to the power of sine squared x. So let me just take that down. 81 raised to the power of sine squared x, right? So this is equal to 27. So this is 3 raised to the power of 4 times sine squared x. That's one value. Now this is nothing but 3 raised to the power of 3. So this is the utmost reduction that we are able to achieve, writing 81 as 3 raised to the power of 4 and writing 27 as 3 raised to the power of 3. Now one good thing is that our bases are equal. So since our bases are equal, I can outrightly state that 4 times. So this would mean 4 times sine squared x is equal to 3, which in turn means sine squared x is equal to 3 divided by 4, which in turn would mean sine x is equal to root of 3 divided by 2. Now sine x is equal to root of 3 divided by 2 has got a positive and a negative. Now when sine x is equal to positive root 3 over 2, then clearly x is going to be, because sine 60 is producing me positive root 3 over 2. I'm just taking the positive value. So x is going to be equal to 60 degrees, so it's going to be pi over 3. If you want to generate for all values, this is has to be added with 2n times pi. Now root 3 over 2 with a positive sign is also generated when you get 2 pi over 3. Sine 120 is also producing me root 3 over 2, but we need all values, so you just add 2n pi. As I mentioned to you, this is obtained from the unit circle understanding. Now taking sin x is equal to negative root 3 over 2, this is going to be giving me x. When exactly is possible for sin x to be equal to negative root 3 over 2? That is possible when you got x to be as 4 pi over 3. To generate all values, we simply add 2n pi. Also, the same negative root 3 over 2 is generated when x is equal to 5 pi over 3. To get all other sets of values, we add 2n pi. So this is going to be the final solution for this question. Thank you everybody. Enjoy your night.